He's been given the name of all names. Jesus, his name is Jesus. He's been given the name of all names. Jesus, his name is Jesus. He's been given the name of all names. Jesus,
I try to mute Ezekiel now so that there can be little or no noise transition into the class. Uh, Said, can you hear me now?
Yes, sir.
Okay. Then Ezekiel too should be hearing me, but don't worry, just concentrate. Don't unmute yourself, Ezekiel. Don't, because of the noise around. Now, we're going to be looking at examples of set. So please focus on it, because by the next class I might give you tests, or either this week or next week you might be facing tests and the results are going to be given to your parents. So just focus on everything. Examples on set theory. Now, we're going to look at a couple of examples today. Let's assume number one example, say in a class of 40 students, 15 like jazz music, while 28 like say Latin music. So 28 like Latin music. That's an information, and the question is, represent the information on a Venn diagram and find the number of students who like both genres of music. Hearing something, so who like both genres of music. So here now we have to represent this in the Venn diagram. That is where we're going to be starting from. Then we have to look for the number of students who like both genres of music. Okay, so please concentrate. Even if you are not going to write anything, I'm not bothered about that. I only need your highest level of concentration, so that when you have the video and you're about to copy the notes, you know what we are doing. Now, solution. We have 40 students is total population. Total is 40. But we can see number of jazz music. Number of jazz music is 15. While number of Latin is 28. Number of Latin is 28. And if you add 28 and 15 together, that is already greater than 40. That is greater than 40. So with that, we see that there is something there that is not usual, and that is where the Venn diagram comes in. Please focus, and Ezekiel, let your face be showing, so that to show you are not being distracted. Now, total is 40, but we have number who like jazz music to be 15, number who like Latin music to 28. So, but we don't know how many people like both jazz and Latin. and that is what we mean by intersection. Call that intersection. In the last lesson, we discussed the meaning of intersection. So that means we're looking for number of jazz intersection Latin. Jazz intersection Latin. So how do we do this? Let's draw a Venn diagram. Venn diagram is drawn this way. Let me divide the page now. To draw your Venn diagram, you need to have something like a rectangle, something like this, and this. Then you bring this up to close it up there, like a rectangle, but you might need to close the rectangle a little bit like this. So such that you're going to, I'm hearing something from side there. You're going to indicate your universal. Universal could be represented by writing this kind of U or this kind of E. So I prefer to use the U. So universal is equal to 40. That is the total number of students. Let me clean this one separately. So the universal is 40. Now, I need to represent jazz and Latin. So I will draw two circles. So the first circle is for jazz, while the second circle is for Latin. The circles are overlapping because we believe there is intersection according to the question. Please, Ezekiel, you are not focusing on this. We believe there is intersection according to the question. So that is why we make it overlap. One circle is overlapping with it. So this one, you are going to label it J for jazz and L for Latin. And from the question, you have that you are looking for representative of both music. That's what we don't know. I'm hearing side from side. Let me mute side so that later on I'm going to ask you to unmute. Now, jazz intersection Latin is represented by X, and that is what we're looking for. But right now, you said 15 like jazz music. That means the total circle of jazz is 15, and I'm already representing this place out of the 15 with. So that means here should be 15 minus X. Because the total should be 15, so I have 15 minus X here. And the total of Latin is 28. I already have X included in 28. Ezekiel, your face is showing. I already have X included in 28, so I have 28 minus X here. 28 minus X. Now, since out of the 40 students, it was never stated that there is none of them that did not like any brand of music. Let us assume that that was included, and let's put it. So let's put it this way: that represent the information in the Venn diagram and find the total number of students who like both genres of music if 3 students didn't like any brand of music, because that is possible. So let me select that and make it. So let's say if 3 students liked none of the music genres. So if 3 students liked none of the music genres, now in that case, you will observe that I said 3 students did not like any. So the 3 will be not in any of the bracket. The 3 will not be in any of the bracket, but it's going to be in the rectangle. So Ezekiel, I don't know what the matter is, but just focus. I said you should focus on it and listen. So the 3 that I just included that did not like any, like none, 3 is going to be here, not in any of the genre. It's not in the jazz and it's not in the Latin, because the 3 didn't like any. So what I'm going to do now is that I'm going to find my X. How do I find my X? My universal is 40. That means addition of everything in the rectangle must give me 40. I repeat that. Universal is 40. That means addition of everything in the rectangle must give me 40. What are the things I want to add to that? The 3, the 15, this x, this x, this x, the 28. So those are the things that must give me 40. And I must take note of the sign between each of the numbers. So let's see. I have 15 minus x plus this x, then plus 28 minus x, then plus 3. So you will observe how many things do I have in the bracket? 1, 2, 3, 4, 5, 6. And I pick them out 1, 2, 3, 4, 5, 6. And I'm taking note of the signs. So everything universal is 40. So for this to be equal to 40, there must be a value for x. This is negative x cancelling positive x. So we have only one x. So I can now say 3 plus 15 is 18. 18 plus 26 is what? That should be 46. So let's see here. 18 or 26, 6 and 4. So this is 46. Now I have 46 minus x equal to 40. So definitely this x can come out and this 40 can come in. Then I have 6 minus 40 equal to x. That means 6 equal to x, or you say x equals to 6. That means 6 then like both brand of music. So if I have to represent this information again on a Venn diagram, I'm just going to draw the rectangle, somewhat like this. And I'm going to say my universal, once again, is 40. My universal is 40. I have the first circle for jazz. I have the second circle for Latin. So then I have the intersection to be x, and my x now is 60. So if my x is 60, I have the total circle of jazz to be 15. So I have removed 6 from 15. What do I have left? I have 9. Then I have the total circle of Latin to be 28. I have removed 6 from 28. What do I have left? 22. Meanwhile, 3 students did not participate. Such that if I add all of these numbers together, it must give me this 40. Now, before I explain the board, I said don't write anything. So even if you don't copy the note, don't bother. The notes will be provided through video. Unmute yourself, both of you, and let us see if you have any question. Yes, Said. Do you understand it, Said?
Yes, sir.
Okay. What about it? Do you understand it now?
Yes, sir.
Okay. Now, in order to show whether you understand it, Ezekiel, before I mute you again, in order to show, where did I get this 3 from? What is this 3 standing for?
X.
Yes. No, this 3 is not standing for x. Said, what is this 3 standing for? Said, what is this 3 standing for? Okay, I can't hear that. Please come again. Yes, the students that did not like any brand of the music. That is 3 students. That is why it was never included in any brand. This is jazz brand. This is Latin brand. The 3 was not included. Ezekiel, I hope that should be clear to you now. So that was why I was stressing it that though you were muted, you should concentrate. Okay, I'm going to clear the screen now. We'll look at another example. Don't bother about the notes. We'll get it in the video later. And all I need now is your 100% concentration. And I believe that's fair enough. So let me clear the screen so that we can look at further example. So let's assume you have example 2 here. Let's assume you have question 2. Set A. Okay, let me use handwriting for that. So let's going to. So let's assume you have set A. A equal to x such that x over 2 is whole number. And b equal to x, or not x this time around, but it can be x again in the same. So b equals to y, such that y is only divisible by 1 and y. Please focus, Ezekiel. Okay, please focus. You have to get these ones. And let's say set c equal to z, such that z is a factor.
So I cannot see the board.
Okay, Ezekiel, you cannot see the board. That means you have to leave the meeting and come in again, so that it will be rectified. Then when you come back, you have to separate. Now, z, such that z is a factor of 60. Z is a factor of 60. And let us now say the universal E is A. Now is A such that A is a number. A is a number A is a number less than or equal to, let me undo that again. A is a number ranging from 1 to 60. Let me put it that way. Okay, this is what you have. I did not give you the members of A. I did not give you the members of B. I did not give you the members of C. And I did not, I think I've shown the universal set to be from 1 to 60. If universal set is from 1 to 60, that means we have numbers 1 to 60 to deal with. But we don't know how many of them belong to A, how many of them belong to B, how many of them belong to C, or how many of them does not even belong at all. So, in this case, we have to list them out first. Let's say the instructions just say represent this information, represent these in Venn diagram. Venn diagram. Okay, before I can represent it in Venn diagram, I have to state out the elements of A. So A must be from anything from 1 to 60 that is divisible by 2. And whatever is divisible by 2 is an even number. So I need all the even numbers from 2 to 60. That is 2, 4. Let me use typeset here so that I can. So A equal to, let me now put Mr. 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 8, and 60. So let's assume these are all the members of my A. These These are all the members of A. And I need to represent B too. I need to represent B. So B is a number such that it's divisible by 1 and itself. That means B is a prime number. So for B to be a prime number means, let me write that out now. So all the prime number between 1 and 60. So here now I have B. Okay, let me close this here. So I have B equals to all of the numbers that are prime from all of these. Yeah. So 2 is a prime number, 3, 5, I mean from 1 to 60, not just all of these, from 1 to 60. So 2, 3, 5. I think I should put that into the description of this one. So, and this one too. Let's say from 1 to 60, so that you can define everything from 1 to 60. Okay, now I come back to this. So 2, 3, 5. Again, let me, because it might be many, so I have to type it out again. So this is going to now be all the prime numbers. So 2, 3, 5, 7, 11, 13, 17, 19, 3, 29, 1, 2, 7, 41, 43, 37, 53, 59. These are the prime numbers from 1 to 65, maybe correct. Let's check it out and see. Prime numbers are numbers that can only be divided by themselves and 1. So from 2, 3, 5, 7, 9, 11, 17, 19, 23, 29, because 21 is not, so 24 is not, 25 is not, 26 is not, 27 is not a prime number, 28 is not, because 9 can divide 27 as well. So 30 is not, 31 is a prime number, 32 is not, 33 is not, it can be divided by 11, 34 is not, 35 no, 36 no, 37 yes, 38 no, 39 no, 39 can divide by 13, 40 no, 41 yes, 43, then 44, 45, 46 no, 47 years, 48 and 49 no, 49 can be divided by 7. So and 50 no, 51 can be divided by 3 and 17, and 52 can be divided, then 53 years, then 54, 55, 56, 57 no, because they can be divided. Then we have 59 and 60 is not included yet. So this is the combination of all the members of B. So we're able to bring this out now. So let me close that page. So after closing this, I need to list all the elements of C. All the elements of C. C are factors of 60 that are present from 1 to 60. So I have 1, 2, 3, 4, 5, 6. The factors of 60. 6, 10, 12. Let's see, 12. The next factor is 15. Then 20. Then 30. And finally, I have 60. So you can see these are the factors. So I have my members of A, then I need to draw the Venn diagram. If all this information are correct, then I represent it in the Venn diagram. going to be needing a very big this thing there. So let me draw such a big rectangle to represent that. So my universal is onto 60, and let's assume this is the circle. Let's assume this is the circle of A, and this is the circle of B, and this is the circle of C. A, B, and C. But I doubt if this is going to contain it. So let me make it a little bit bigger. So if this is A, and this is B, this is C. So I put A here, B here, put C here. So having these three, I'll begin to look at what is common to all of them first. That is in here, here, and here. I can see 2. So I put 2 in a place that is common to all of them, followed by what else is common to all of them, to A, B, and C. 4 is here, is not A, so 6, no. So definitely, it must be only 2 that is common, because since no prime numbers can be here, and no prime number can be, the prime numbers, all these can be prime numbers. So then it's only 2 that must be in this place. So let me clean that and write the 2 very well. Now let me now check A and B. What is common to only A and B? So for only A and B, I have 2 in A and A. Okay, I've picked 2, so 4. Definitely there is nothing common to only A and B. And let's check B and C. B and C, we have some things common. This is 3 and this is 3. So in circle of B and C, I can put 3 here. Then, is there any other thing common that is here? And it's also in C. I don't think so. There is. Okay, there's 5. There's 5 here. It's 5. So I put 3, 5. Now, what about A and C? Is there anything common in A and C? Okay, I've considered that. So I now have to identify. So right now I'm going to go ahead to solution to the other question on how to draw the Venn diagram. So let's see. From the question, we were able to identify that set A, and put it in place now. Set A. What did I call set A? What did I say are the members of set A? They are even numbers, right? Even numbers from 1 to 60. Now set B, call the prime numbers. Prime numbers from 1 to 62. And set C, we call them factors of 60. Factors of 60. So we're now trying to compare that in Venn diagram. Let me draw this Venn diagram now. So we're going to have something like circles to represent them. So if this is A, and this is B, and this is C, then let's say A, B, C. So let me get it. Now in set A, we have even numbers, and set B, we have prime numbers. Prime number, the first prime number is 2. So that means there's something common to A and B. So A intersection B, and also is in C. So intersection C as well is 2. It is the only number common to this, so this is the point. Then let us now consider A and B. A intersection B. Whether there is anything that is in A and also is in B, apart from 2 that we have. So from 1 to, even numbers from 1 to 60, apart from 2, start from 4, 6, 8, 10, and so on. So could there be 4, 6, 8, 10, blah, blah, blah in this B? No, because all those numbers are not prime numbers. So we now say the only A intersection B is 2, which is already in the A intersection B intersection C. So if they ask us for A intersection B only, then that is an empty set because there will be nothing in that region. There will be nothing there. So A intersection B, there will be nothing in this region. But let's check B intersection C. B intersection C. Let's see, apart from, so let's see B intersection C only because we have removed the 2 now. So for B and C, B are prime numbers, C are factors of. So the only factor of, apart from 2, the only factor of, okay, there are 2 factors of 60 that are prime numbers, which are 3 and 5. So here we have 3, 5. We have 3,5. So we here B and C now have 3,5. And that's what I was trying to explain. Then we have A intersection C now. A and C. Now, in A, we said A are even numbers. C are factors of 60. So that means we have to pick all the factors of 60 that are even numbers, starting from 4. So A intersection C only now. So starting from 4, we have 4, we have 6, we have 8 as even number, but it's not a factor of 60. So we have 10, we have 12, then we have also 20, we have 30, and we have 60 itself. So these are all the things that will be in A and C together. So 4, 6, 10, 4, 6, 10, 12, 20, 30, and 60. So once that is certain, then we can start fixing the empty spaces that remain, because this place now we say should be empty. So what are the elements of A? Even numbers from 2 to 60 now. So we have seen 2, 4, 6 remain 8. We have seen 10 remain. We have seen 12 remain 14, 16, 18, we have seen 20 here because it's in A also. So remain 22, 24, 26, 28, we have seen 30 here, 32, 34, 36, 38, 40, 42, 44, 46, 46, 48, 50, 52, 56, 58, and 60, but 60 is already here, so I don't have to repeat it. Now, let's go to B. B are prime numbers from 1 to 60, and prime numbers start from 2. So we have 2, 3, 5, then the next should be 7, 8, 9, no, 11, 13, 17, 19, 23, 29, 31, 37, 42. Oh no, sorry. 42 is not a prime number. It's 41 I wanted to. So 41, 43, 47, 53, then the next should be 59. So these are the remaining prime numbers that are supposed to be in B, apart from this prime number that has been removed. Now C are factors of 60. So let's see which factor of 60 has not been included in this place. So 2, we have 2. Okay, 1 has not been included. 1, 2, 3, 4, 5, 6, 10, 12. Then we have 15 that has not been included. 15, 20, 30, and 60. So it's only 1 and 15 that is in this place. So 1, 15. So this is how to. Now let us check if there is, because our universal is from 1 to 60. So let's check if there's any member of 1 to 60 that has not been represented here. Let's check. We have seen 1, 2, 3, 4, 5. We have seen 6 somewhere there. We have seen 7. We have seen 8 here. Where is 9? Is there 9 anywhere? There is nothing defining 9 here. So 9 should be here because it's not a member of any of the circles. Then 10 is contained. 11 is contained in prime number. 12 is contained. 13. Okay, 13 is contained here. 14 here. 15 in the factors. 16 here. 17 here. 18 here. So 19 here. 20 is already here. 21. Where is 21? 21 has not been catered for. Then 22 is here. 23 is here. 24 is here. 25 has not been catered for. Right? Not part of it. 26 is here. 27 has not been catered for. 27. So in a nutshell, we are looking for all the prime numbers, all the odd numbers that are not prime numbers. So 27, then the next should be 33, the next should be 35, the next should be 39, the next should be probably 45, next should be 49, should be 51, 51. The next then should be 57, 57, and finally 59. So as 59 has been catered for, so that's not it. That is a prime number, so I undo that. So with that, we come to the end of this class. You can unmute yourself now, Said. Now, do you understand where I have arranged the Venn diagram? Okay. What if they ask you to list all the members of A intersection C? You are going to list all of these, including the 2. But if they say A intersection C only, you remove the 2, you list this. If they say B intersection C, you list these 3 elements. But if they say B intersection C only, you list only this place. They say A intersection B, you list only 2. But if they say A intersection B only, you remove this empty space. Now, if they say elements of A, you list everything in the circle of A. But if they say elements of A only, you will not list all of these that overlap only. Then the same thing goes for B and C. So is that clear to you? Okay, thank you very much. So I expect the video to be class probably before the end of the day, if possible, tomorrow. Is that taking?
Yes, sir.
I'm going to be ending the class now, so you have a nice time. Bye.
Jesus.